So in part B of this question, we're given again these particles A and B, and we are told that they're held in place at the two vertices of the triangle. And students want to represent the electric potential energy of the system of particles when we have this third particle brought from very far away to the bottom right vertex. In this first scenario, we bring a positive charge Q from very far away to the bottom right corner, and we're told that this UI1 initial is just the initial energy of the system, and we need to draw bars representing the work needed to move this third particle and then the final total energy of the system. So to do this, what we need to consider is that when we had the charges like this, so we had the plus Q here, and then we have to bring it to this bottom right vertex, we can consider the total energy of the system before this third particle is brought. Here we only have this. So the total energy of the system is just like the energy needed to assemble the system. And therefore we can say that the energy is simply going to be Q times the change in potential. So that will simply be the charge, for example, for this charge is big Q, and the potential at that point is simply Q times KQ divided by small d. So this is KQ squared over d. So this is the initial energy of the system. And then we can consider the work required to bring another particle here. Well, for that, we can again just use the same formula. So the work will be the Q times the change in potential. However, now we have two charges that we need to bring it to. So the potential of these two charges we need to consider here, and they will add up. So the charge will again be big Q, and then the change in potential will be K times Q over D, plus for the other charge as well, K times big Q over D. So this will be 2K Q squared over D. So we can see that the work is double than the initial energy. So what that means is that the work will require twice as much energy that compared to the initial energy. And well, for the final energy is simply the initial energy plus the work we put in. Oops, I drew it a bit too big. It should only be double, so this is 2 units. So this should be 4 units. And yeah, so the final energy will simply be the initial energy plus the work that we put in. So that will be 4 plus 2, so that will be the entire height of this section over here. And then in part scenario 2, we have a negative charge, and we do the same thing, and we need to represent the works. So the only thing that's really going to change here is the sign of the work. So if we consider the sign of the work, now we have a negative Q over here. So that will make the work minus 2K Q squared over D. So not only will it be double, but it will also be the other sign. So the work will be negative 4 units. And again, the final energy is simply the initial energy plus the work done. So if we add this with this, plus 2 minus 4 is going to be minus 2. So this will be the final energy of the system.